100%. Okay. That's what I mean could. So I mix the I poured this into this. Okay. 100% is 100 divided by 100 is like just 1. Basically it's just an X over there. Okay. So what will be our equation? Anyone? Will be what? 0.94, right? Time 200
Plus x
plus x over e
equals
0.98
times 200
200 plus x.
x.
And go ahead, distribution. Combined line term, you have x 400. 400 what? 400 liters. Distribute first, then combining line term, same way as you do for this. Okay. All right, let's do. Everybody clear? Any question on this? Or are you guys still working on that? I'm gonna wait a little bit more. Just give you guys more time. All right. Any questions so far? All right. Let's see. We can do this problem together. I see the very good question here. I don't know if it's feasible or not, but we try. Okay. Just read it. I think we can do this. All right, let's start with this problem right now. A passenger train left the station and traveled toward the repair yard at an average speed 29.2 kilometers per hour. And another train left 2.4 hours later and traveled in the same direction, but with the average speed, so the speed is 36.5. Okay. How long did the passenger train travel before the cattle train caught up? Oh, that's an interesting problem here. A cattle train left 2.4 hours later. Okay. And travel in the same direction. Okay. Travel in the same direction, but with the speed of 36.5. How long did passenger train to touch before the cattle train caught up? So what do you guys think? Okay. let me erase this. It should be feasible. Yeah, go ahead, work on that problem together. So let me do a quick summary here. So the passenger train, the speed is 29.2.
29.3,
29.2
X.
kilometer per hour. And the other train is left 2.4 hours later and traveled the same direction. This cabin train. The average speed is 36.5. How long the passenger train traveled before the cattle train caught up? Oh, wow. How we do this? So what do you guys think? What do you guys think? How
I
long?
probably did. I was gonna go based off of last night.
So you can call T as the the number of hours, right? The amount of time the passenger train travel.
I
Okay,
was going based off the notes of his last one.
that's T. How do you guys do it? Kind of interesting. It's kind of interesting problem. How long the passenger train traveled before the cattle train cut off? The information that 2.4 hours later is very important. So you need to find a relationship between T and 2.4 hours right there. Anyone want to come here and try this problem? Anyone come over here and do this problem and give you guys one? Oh, no Google, okay? No Google. No Google. Well, I mean, if you Google, you gotta explain to me how. But I don't think they have a solution. So in order to get 1 point, you gotta explain to me how. So what does it mean by, you guys understand this? How long did the passenger train travel before the cattle train caught up?
So they're equal. The distance.
The distance should be equal, yes.
So it's
Zero
It's
Are we solving for distance?
No, we solve it for time. You're gonna ask you for time.
so would it be 36.5 t minus 2.4 equals 229.
This is what I got. I don't get it like at all.
Equal 29.2 t.
Yeah, that's
Right there. What is the 65?
Go ahead and solve it. Go ahead and solve it. What you get? Go ahead and try to solve it. Let's see what you get. It should give you a nice number. I think so. It doesn't give you a nice number?
No.
B40.
Is it the right equation?
T 2.4. You say T minus 2.4? Okay. Anyone? If you go ahead and solve your equation, what you get? It doesn't give you a nice number. Now, what do it give you?
0.328.
I don't think it's correct.
We got 15 on the two.
All right, come over here. Come over here. Come on. 1 point. Why not? Come here. 1 here. Go ahead. Because right now I haven't solved it. I don't know the solution. I cannot check for you. But I can check your work. I can check your I can check your equation only because I don't have calculator. So I can. Go ahead. Anyone? Go, come on, 1 point. Oh my God, really? 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 I want to ask you a question, okay? Hopefully you can answer. Do you think that most of the trains started at the same position?
No.
I'm even talking about the same location.
No, the passenger train left the station towards the repair yard, and then Carol's train left 2 hours. Oh, well,
Yeah, they
Yeah,
did.
They do?
Yeah.
They start at the same location, right? The same station. But just the other one is they start 2 hours later. 2.4. Come on. I'm waiting on you guys. Be brave. Be
So
brave.
would you solve it as your, like 2 different equations?
No, only one.
No, just
Only one. Only one good variable, yes. I have to check for you in order to give you credit. In order to give you credit? Why not? Wait a minute. Why do you right over here then I can check for you?
what if we get
Come on. What if you get it wrong? You don't have anything to lose.
Did you make fun of me?
Come on. No? Still no? No? Okay. No one? How about over here? Anyone over here? I think you kind of close. You just mess up a little bit. The 2.4 hours later. That's where you mess up.
Oh, I subtracted. I should have added.
Yeah. You should. So if you add it, right? Yeah. So think about that. 2.4 hours later, it means the amount of time the cattle train travel, okay, it should be less
Yeah.
or more or less. Oh, you just say yes. More or less.
Wait, what?
It could be less. Less. 2.4 hours later, that train is caught up with the other train already. Okay?
So this is 2.4 hours.
Alright. So this is the equation, okay? So first of all, we need to find the distance the passenger train travel, which is 29.2 t. Right? And they should travel the same amount of distance. Right? Because they start, that's why I'm asking you, they start at the same location or not? If they start at a different location, oh, we have a big problem. Because the distance will be the same. Right now, this distance is the same. So this is the distance the passenger train travel. Okay? It should be equal to the distance the other train travel. Okay? So the other one travel at what speed?
36.5.
36.5. Time?
Plus 2. Oh.
You kind of close. Alright, so you have 29.2 t equal 36.5 t. Please give me the answer for this. 36.5 times 2.5 give you what?
2.4, isn't it? Probably 2.5.
It's 2.4?
Yeah.
Oh, thank you. 36.5 times 2.4 is?
It's 87.6, right?
Yes.
7.6?
No, 87.6.
87.6. Oh, something not right.
Yeah.
Because right now we got t is the t is minus number. So when we set up something wrong, we set up something wrong, right? Because right now, look at that. 29, 36.5, 2.4 hours later. So that is the way we got it wrong. We still do something wrong. So we thought it wrong already. You see that? Because right now, look at that. Right now, if we go ahead and do subtraction, you see, subtract both sides by 36.5 t, right? It give you minus. It give you minus. And over here, positive. Go ahead and divide both sides by minus. Give you t minus. So it's still something. So probably we think something wrong about 2.4 hours later. 2.4 hours later. Do you have the same equation? What do you have? What do you have?
We have 36.5 parentheses 2.4 plus 29.5x t.
What?
I don't know.
2.4 hours later. Just think, 2.4 hours later. Just think about like the first train start at 7 a.m., right? And 2.4 hours later is 9 a.m. So it should be correct. It should be correct. It should be plus. But for some reason, somehow, I think that's the typo right here with the number. It should be correct. If 2.4 hours later should be addition. Yes, because more time traveling. So this, the way we set up, it should be correct. But I think there's something wrong with the number. Something wrong with the number. That's why. Okay, so that's why it's not working. support. That's why it doesn't work. And your equation is kind of, I don't know what it's kind of weird, right? It kind of.
No, I realized what I did wrong.
Let me take a look.
No, no.
Why? Let me take why? Let me see. Hold on. Why?
No, I know
What's
it's
wrong?
okay. So
Let's see.
what I had did, I thought it was like, I thought it said that so since the cattle train was already, I mean the 29 passenger train was traveling for 2.4 hours, so multiply 29.4.
No, it's yeah.
So I
Yeah,
know what I did wrong.
Yeah. We should have it correct, but I think something wrong with the number. So, but unless we even though we don't get the final answer, but the way we learn that, the way we set up, we really want to understand. That's why I want you to understand this. 2.4 hours later. 2.4 hours later. It should be add or subtraction. That's the question. That's the question. 2.4 hours later. It means that,
Yeah, ahead of time.
yeah, 2.4. He traveled less. So the cattle train travel with more, the question we want to ask ourselves is this. Is the cattle train traveling with less amount of time or more? It's 2.4 hours later, that cattle train already caught up with the passenger train. So that's the question we want to ask. It's traveling less or more? Less. It's not more. So you got it right. Traveling less. Because it's 2.4 hours and he already catch up. He already catch up. The cattle train already catch up with the passenger train. Right? Right? Just think about that. Just think about it. So it should be less. It should be less. And because it should be less, it's minus. So you got it right. He got it right at the beginning. But that is kind of killing us right there, right? It's kind of killing us right there. All right. So go ahead. 29.2 minus 36.5 give you. Give you what? Come on, anyone? 3, right? 1, 7. Right? 17? Is that correct? Okay. Minus equal 87.6. And t equal 87.6 divided by 17.3. I'm gonna do everything one more time. Just check everything one more time.
29.2 minus,
That is, I got it wrong.
yeah, it's.
Okay, that's what I'm checking right now.
Yeah, it's 7.3, not 17.3.
It's 7.3.
Yes, 7.3.
And now 87. Thank you for that. 87.6 divided by 7.3. 12. So that is the part right here is important. 2 hours later, here that train already caught up. It should be less amount of time, not more. Not more amount of time. Yeah. Everybody clear on that? Just think about it. Just think. It should be less, not more. Okay. When you keep thinking about that, okay, so just think, okay, that guy traveling to, and because you see, the cattle train traveling faster It's traveling faster, then of course it's less amount of time to catch up with the other train. Okay? Everybody clear on that? Good now? Okay. All right. Let's see what else. We still have time, huh? Oh, wow. Okay. Let's see. Let's see if we can do something else. Oh, we have a lot of word problem here. I can pick any one and we can practice together. This is the it's SAT problem, so we just have to do it. Oh, how about this? How about this? I don't know how to do that now. I haven't read it, but I'm gonna read it. And we're gonna work together. Okay, we're gonna work together. Okay, while he left the White House, okay. Kelly left the White House and traveled toward the lake. Okay, I don't know how I'm gonna pronounce this name. Weber left 1 hour later, traveling 15 miles faster in effort to catch up to her. Oh. After 2 hours, they finally caught up. So kind of the same as this. Yeah, this one is 2.4 hours later, right? And this one is just 1 hour later. Try to do that. Go ahead. Now, what problem is it's not easy, especially when you deal with time, rate, and distance. Your reading comprehension must be really good.
Oh yeah.
I mean, it's English. You guys born here. It must be better than mine, right? No? No? It's the reading comprehension. We require very good reading comprehension. Believe me, if you throw this problem, we in college we have to do this, but if you throw this problem to like 40 years old guy, 50 years old guy, you couldn't do it. I'm sure. But this is what we have to do. Word problem, because we set up the linear equation for that. It is linear equation. The thing is, how are we going to translate it? So this is have more things 15 miles faster. Okay. So after 2 hours, they already caught up. So that 2 hours is fixed. It's not changing. Okay. No, maybe I'm gonna put that on the test. But I'm sure that I'm gonna put the mixture problem on the test. I'm sure. Okay? Mixture problem must be on the test. Not just if it's not on the first test, then it must be on the final. Please take your time. Time. So, oh, someone's got it, huh? Where's my, got it? Got it? What was Kali average speed? Oh, I just named X represent Kali speed. Because that's what you want to find. Name variable X for that. Now, think. So if X is representing Kali speed, what is the speed of Niba? What is the speed of Niba? 15 miles faster, so 15 plus X, right?
Yeah, 15x.
15 plus X. 15 plus X. 15 plus X. That's the speed of Niba. And after 2 hours, so this 2 hours is fixed. Okay. If you multiply by the speed and the number of hours, after 2 hours, then left 1 hour later, then left 1 hour later. Then after 2 hours, what does it mean by that?
2 hours.
Oh, wow. It's a crazy problem, huh? After 2 hours, so now they left 1 hour later.
That's plus 1.
Then after 2 hours, now they are finally caught up.
Subtract 2.
What is the average speed of Kali? So we're gonna have something like this. Because they caught up, so we're gonna have something times X and something times 15 maybe something times this equal to something times x here. Like that. Okay. Two hours later, and then it finally catch up. It should be 2 here or here. So 2 hours later is the amount of time is Nadia traveling. This is the amount of time Nadia traveling. So it should be 2 should be over here. 2 hours this is the distance Nadia Niba travel. After 2 hours, Niba finally caught up. Then what is the amount of time Kali travel? It's 2 minus 1 or 2 plus 1. So we said we had the same problem like last time, you remember? So same problem that Nadia left 1 hour later. 1 hour later. So it should be 2 or 3. It should be 1 or 3. So that's the question we need to ask.
Is it 3?
That should be 3. That should be a negative.
If it 1, then it should be negative, right?
Yes.
If it 3 is negative, no, if it is 3 it's not
Yeah,
negative.
it is.
It's 3.
That's how you check.
It's 3.
It should be 3. Because if it's 1, just think about if it's 1, then how are you going to solve for x? You're going to solve x turn out to be negative number. It doesn't work that way. So it should be 3. And just think about it. Just think about it. 1 hour later. So it should be 3, it's working. Right. It makes more sense with 3 than 1. So from here I have 3x equal 30 plus 2x. So with x equal 30.
Yeah.
That makes sense. 30 miles per hour. And you can find Niba speed is 15 plus 30 could be 45 miles. Is that kilometer per hour?
MPH.
Mile, mph. Yeah. Okay. Cool. All right. So I think it looked like the mixture problem is kind of easier than distance rate time problem. Okay. And let's see what else we can do. Oh, this is. Let's do something. Let's see. Let's see. I can come up with this. Any questions so far? You see, you can find a bunch of word problem and you can practice with it. You know, anything you want to be good at, you have to practice. Okay. And I just want let's go through this. Okay, we have solution already. Let's go through this together. So consecutive integer that follow in the sequence. A number being one more than the previous number, represented by n plus 1, n plus 2. That makes sense because the consecutive integer is 3, 2, 1, 2, 3, 4, 5, 6, 7. Consecutive. So, and they say what? Find 3 consecutive integer whose the sum is 655. Okay. If you name n represent the first number, then the next consecutive integer must be n plus 1, right? And the next one must be n plus 2. Then, and they say what? The sum is 657. So we're gonna add up n to n plus 1 is the second consecutive integer plus the third consecutive integer. Add all these 3 up, give you 657. So this is a very typical example. I'm sure that you will see this on MyMathLab. 90% of them. Okay. Then you're gonna combine 9 terms. So for n, and n should be the first consecutive integer. Integer. Okay. Any question? Any concern? Okay. All right. Any other concern? Otherwise, I think we can stop a little bit early today, 10 minutes early. So again, go ahead, finish the homework. Let me know if you have any concern. Keep up with all the homework. Work together on assignment, then I'm sure that everything will be fine. All right, and I'll see you guys next time for the next section.
Those, you want to work with me? Yeah, office. What? There's an office.
I think I took the time.